Hello class. Aggregate crushing value test. Let us understand how to determine the crushing value of aggregate. This method covers the procedure for the determining the aggregate crushing value of the coarse aggregate. You can refer Indian Standard 2386 Part 4 1963, Indian Standard 383 1970, apparatus used for the finding the crushing value of the aggregate. You have to use the aggregate crushing value apparatus, Indian Standard sieve 12.5 mm, 10 mm and 2.36 mm, cylindrical measure which diameter is 11.5 and height is 18 centimeter. You can see in this photo the diameter of the cylindrical measure is 11.5 and height of the cylindrical measure is 18 centimeter. And cylindrical mold is also used for finding the crushing value of the aggregates, which dimension is 15.2 centimeter in diameter and 13 centimeter in height. You need compression testing machine for applying the compression load, and you need balance. Let us understand detailed procedure for finding the crushing value of the aggregate. First of all, you have to take 6.5 kg of the sample which is passing from 12.5 mm sieve and retain on 10 mm sieve. It means you have to take the soil, you have to take the aggregate uh, dimension should be between 10 to 12.5 mm. And now fill the aggregate in this cylindrical mold, but you should fill these aggregates in 3 layers and each layer should be tempered by the tamping rod with 25 times. The dimension of the tamping rod is 16 centimeter diameter and 60 centimeter height. So you have to fill these aggregates in this mold in 3 layers and each layer should be tempered by 25 times, and dimension of the tamping rod is 16 centimeter diameter and 60 centimeter height. The weight of the sample in the cylindrical measure is taken 1. This is the W1. Then fill the aggregate from the cylindrical measure to the cylindrical mold and level the top of the surface of the aggregate in the mold and place the plunger. You can see in the photo, place the plunger on the aggregate. Now your setup is ready for loading. Place the mold with the plunger of the compression testing machine. Now you have to put your setup on the compression machine for applying compression load. Apply gradual compressive load of 40 tons in 10 minutes and release it. You have to follow all the steps as per the Indian standard. Just you have to apply the up to the 40 tons in 10 minutes and then you have to release it. Remove the crushed aggregate. After got the compression load, the aggregate got crushed, and remove the crushed aggregate from the mold and sieve it to 2.36 mm and fraction particles. You have to weight that. This sample will give you the weight 2. It means now you have a W2. First one is a W1 and second one is a W2. What is W1? The weight of the sample contained in the cylindrical measure. What is the W2? The fraction passing sieve is weight 2, W2 after the compression load. Now you can easily calculate the compression aggregate crushing value test aggregate crushing value by W2 by W1 multiply by 100. What is W2? W2 means fraction passing the sieve is weight W2, and what is W1? The weight measured in the cylindrical sample. You can calculate by W2 divided by W1 into 100. W1 means weight of the saturated surface dry aggregate. What is W2? Weight of aggregate passing from 2.36 mm IS sieve, and you can calculate by W2 divided by W1 into 100. Now you have a result in percentage. But remember one thing, the aggregate crushing value should not be more than 45 percentage for aggregate used for concrete other than for a varying surface, and it should not be more than 30 percentage for concrete used varying surface such as runways, roads, and airfield pavements. So you have to find out the crushing aggregate crushing value, and it should not be more than as per the Indian standard criteria for particular structure, for particular design. So this is the procedure for finding the aggregate crushing value test. Thank you. Let us understand the flakiness and elongation index. First of all, what is the flakiness index and what is the elongation index? Flakiness index means this is the percentage by the weight of aggregate which least dimensions, you can say thickness of the dimension, is less than 60 percentage of the mean dimension of the aggregate. Is known as the flakiness index. What is the elongation index? Percentage by the weight of the aggregate which greatest dimension of the aggregate, you can say length of the aggregate, is greater than 180 percentage of mean dimension of the aggregate. So we have to find out the percentage of the flakiness aggregate and percentage of the elongation aggregate, because this type of the aggregates will affect to our concrete mass. Our object is to determine the value of flakiness index and elongation index of aggregates. You can refer Indian Standard 2386 Part 1 1963, Indian Standard 383 2016, Indian Standard 460 1962. Let us understand the apparatus used for the flakiness index. You can see in the photo this type of the gauge, used for the finding the flakiness index, and you can understand these gauges are provided in this gauge. For example, you have a aggregate between 10 to 12.5 mm. It means this portion will be used. It means 10 mm to 12.5 mm. What is the thickness of this portion? Thickness of this portion can be calculated by 10 mm plus 12.5 mm divided by 2. It means you have to calculate the average size of the aggregate, multiply by 60 percentage. You can multiply by 3 by 5 or 0.6. Now you can get this value 6.75 mm. This is the thickness of this gauge. So this gauge used for the finding the flakiness index. And next one is a balance, gauging trowel, stopwatch, Let us understand in detail how to define the flakiness of the aggregate. First of all, you have to take the sufficient quantity of the aggregates, like minimum number of the 200 pieces of the any fraction can be tested. You can take 10 to 12.5 mm, you can take the 16 to 20 mm, and you can take the various size of the aggregate for this performance. It is dependent on the quantity of the aggregate and size of the aggregate which you are using at your site. For example, I am taking 16 mm written and 20 mm passing. 16 mm written and 20 mm passing. So thickness is 10.8 mm you require. It means this thickness is 10.8 mm. You can see in the photo. Now, what is the next procedure? This all aggregate you have to pass from this portion. This is the 16 and 20 mm, 16 mm written and 20 mm passing aggregate, and just you have to pass this aggregate, and you can get the passing aggregate and you can get the written aggregate. So passing aggregate which shows which thickness is less, it means this is the flakiness aggregate. And now you have to pass the aggregate from this side and you have to collect the aggregate from this side. So you can calculate by the written aggregate and passing aggregates. So, and there is a there may be small aggregates like finer materials like less than 75 microns, which is very small size, that may be wasted in this procedure, and each fraction is then gauged into the in turn for the thickness of the thickness gauge. You can say the thickness gauge of the aggregate. So you have to weight of the aggregate passing through this thickness gauge, and you have already taken the sample of the aggregate. Now you can calculate the percentage of aggregate passed from the thickness gauge. This shows the flakiness index. I repeat again. First of all, you have to take the aggregates. You can take particular one size, or you may have to take the different type of the aggregate with different set of the aggregate, and you have to perform in different gauges, and then you have to calculate just passing of the aggregate, and you have already taken the sample. You have taken the sample for this procedure. This is the W1, and passing aggregate, this is the W2. Now what is the flakiness index? W2 divided by W1 multiplied by 100. It means you can get the flakiness index of the aggregate. This is the simple. So the percentage of the flaky aggregate in it should not be more than 10 to 15%. Otherwise this will affect to your property of the concrete mass. So we have to find out the flakiness index of the aggregates. Understand, for determining the elongation index of the aggregate, you can see in the photo this type of the length gauge we are using for finding the elongation index, and you can say the different lengths are available on the length gauge. You can see for the first portion is 6.3 mm written and 10 mm passing. Second portion is 10 mm written and 12.5 mm passing. Third one is at 12.5 mm written and 16 mm passing. And next the 16 mm written and 20 mm passing. For example, this length you can calculate by 16 plus 20 divided by 2. It means the average size of the aggregate multiplied by 180 percentage. It means 1.8, and you can get 32.4 mm. So you can calculate the length of this portion in the length gauge. Let us understand the procedure for finding the elongation of aggregates. A sufficient quantity of aggregate is taken such as the minimum numbers of 200 pieces of any fraction can be tested. For example, I am taking 16 mm return and 12 mm passing of the aggregate. It means I have to pass the aggregate from this portion, which length is 32.4 mm. It means aggregate will pass which length is less than 32.4 mm, or aggregate will retain which length is greater than 32.4 mm. Clear? So I have to pass the aggregate from this portion 16 mm written and 20 mm passing. I have to pass the aggregate. If aggregate is written, it means the length of the aggregate is greater than 32.4. If the aggregate can pass from this portion, it means it shows that the length of the aggregate is greater than 32.4 mm. So if the aggregate length is greater than 180 percentage of the mean dimension of the aggregate, which is that 32.4, is known as a flakiness aggregate, and this will affect to our concrete mass. So we have to find out that this type of the aggregate, which is the elongated aggregate, and we can calculate the percentage of elongation aggregate. The material is then washed and sieved so as to remove the material finer than 75 is micron, and each fraction is then gauged in the turn for the on the length gauge. We have taken 16 mm and 20 mm, means 16 mm written and 20 mm passing. Elongation index means the total weight of the aggregate or written on the various length gauge. If you have a different type of different grades of the aggregate, so you have to pass the all these gauges. Currently I have taken the only one grade of the aggregate, one type of the aggregate, which is the 16 mm written and 20 mm passing. So you can calculate elongation index, total weight of the aggregate written on the various length of the gauge divided by total weight of the sample you have taken for this procedure, multiply by 100. You will get in the value in the percentage. Remember that the percentage of the elongated particle is should not be more than 10 to 15 percentage. This will be undesirable for the concrete mass. This will affect the on our concrete mass. So we have to calculate the flakiness and elongation index.